So next we are going to the next topic, Cayley-Hamilton theorem. Cayley-Hamilton theorem says every square matrix satisfies its own characteristic equation. This is the statement of Cayley-Hamilton theorem. Every square matrix satisfies its own characteristic equation. That means if you take A, if you write characteristic equation for A, that will be in lambda. If you replace lambda with A, then if you evaluate, finally you will get a null matrix. So that is very most important application in matrices. So which says every square matrix satisfies its own characteristic equation. Here our work is we need to verify Cayley-Hamilton theorem for given matrix. To verify Cayley-Hamilton theorem for given square matrix. For given square matrix we are going to verify Cayley-Hamilton theorem. For that, first write the given matrix. Let A be the given matrix. A be the given matrix. Next, write characteristic equation of A. Characteristic equation of A. You know how to write, that is det A minus lambda I equal to 0. Next, third one. Now evaluate lambda equal to A characteristic equation. That means nothing, simply we can say, simply substitute in the place of lambda A in the characteristic equation. That means evaluate means here nothing you are going to do. You are going to substitute lambda equal to A in characteristic equation. Next, evaluate. Next, find A square A cube. After finding A square A cube, because the characteristic equation in lambda cube, lambda square, if you write in the place of lambda A, you will get A cube and A square. That's why find A square and A cube. Next, substitute this A square, A cube and identity matrix in characteristic equation in A. In characteristic equation in A. That means after writing lambda equal to A, the equation will be in A. That is called matrix polynomial also, because that is an equation in matrix. That type of equations we can call it as matrix polynomial. In that matrix polynomial, you need to substitute A square A cube I. After substituting A square A cube I in equation in characteristic equation in A, if you evaluate, if you simplify, we will get a null matrix as answer. Null matrix. That means that A matrix is satisfied characteristic equation. That A matrix is satisfying its own characteristic equation. This is the procedure to verify Cayley-Hamilton theorem. Similarly, the most important application for Cayley-Hamilton theorem is finding A inverse and finding powers of A. That means A power 4, A power 5, A power 6, like that. We can find using Cayley-Hamilton theorem without calculating directly. That means without using A inverse formula, one can easily find A inverse. To find A inverse, what we need to do? Divide the characteristic equation with A. Divide characteristic equation with A, or multiply with A inverse, any one. Multiply with A inverse or dividing with A, or both are same. But generally in matrix we don't have division. That's why so many textbooks follows like multiply characteristic equation with A inverse, both are same. After dividing, send all the terms to RHS. Send all the terms to RHS except A inverse. And calculate. Except A inverse and calculate, you will get A inverse. So first divide the characteristic equation in A with A. then send all the terms to RHS except A inverse and simplify RHS terms, you will get A inverse. But to verify a Cayley-Hamilton theorem for a given square matrix, to evaluate this A square A cube manually, little bit difficult and time taking process. For that, we are going to take help of Casio scientific calculator. In that calculator, one can easily calculate A square and A cube. Okay. So now we are going to verify Cayley-Hamilton theorem for this matrix, that is not given directly like this. Show that this matrix satisfies characteristic equation and hence find A inverse. That means statement of Cayley-Hamilton theorem is given in the question. First, we need to verify Cayley-Hamilton theorem for this matrix A. If you have question like that also, the same procedure. For that, what we need to do, first we have to write characteristic equation. Characteristic equation of A. Characteristic equation of A. What is that, ma? Det A minus lambda I equal to 0. Subtract lambda from the diagonal, ma. If you subtract lambda from the diagonal, 1 minus lambda minus 2, 2. 1 minus 2 lambda 3. 0 minus 1 2 minus lambda equal to 0. After this, you need to find characteristic equation. I said how to find characteristic equation using one simple technique, that is minus lambda cube plus sum of diagonal elements into lambda square. If you add diagonal elements, you will get lambda square coefficient. So 1 plus 2, 3. 3 minus 2, 1 lambda square minus sum of cofactors of principal diagonal. Sum of cofactors of principal diagonal means one cofactor. If you see minus 2, one cofactor I am calculating. For one cofactor, one corresponding column row is eliminated. Minus 2 into 2, minus 4 plus 3. Minus 4 plus 3, minus 1. For minus 2, cofactor is minus 2 corresponding column row is eliminated. 1 2 are 2, 2 minus 0, 2. For 2 cofactor, last row, last column is eliminated. Last row, last column is eliminated. Minus 2 plus 2, 0 you will get. 2 minus 1, 1. So sum of cofactors is 1 again, lambda plus det A. Det A, you know how to calculate det A. Plus minus plus 1 into 1 cofactor is here, minus 1 plus 2 into 2 corresponding column row is eliminated. 2 minus 0, 2 you will get. Finally, last element cofactor plus 2 into 2 corresponding column row is eliminated, minus 1. So what you will get, minus 1 plus 4 minus 2. So 4 minus 3, this one also 1. So this is characteristic equation in A. Here, write in the place of lambda A. This is characteristic equation in lambda. Replace lambda with A in this. What you will get? Minus A cube plus A square minus A plus 1 equal to 0. Now, we need to calculate A square and A cube. We have to substitute so that we will check whether characteristic matrix A is satisfying characteristic equation or not. For that, first to calculate A square, you know how to calculate A square. A into A. Multiply A 2 times. Then you will get A square. This one we can easily calculate in calculator also. I will tell you how to calculate in Calci also. If you have Casio, Calci, that is FX991 ES or FX991 ES plus calculator. In that, one can easily calculate A square. To calculate A square, A cube, det A, everything, first you need to save the matrix in the calculator. To save the matrix in the Calci, to save A, what you need to do, on the Calci and press mode, press 6, press 1, then enter elements. Simply enter these 9 elements. How to enter? 1 equal to, minus 2 equal to, 2 equal to, 1 equal to, minus 2 equal to, 3 equal to, 0 equal to, minus 1 equal to, 2 equal to, like that you need to enter. After entering elements, press AC button. This means matrix A is saved in your calculator. Next, to find a square, what you need to do? Press on. You should on the calci, then press shift 4 3. Shift 4 3. Then you will get a in the display ma. Then press x square. Next equal to x square button will be there. Then you will get a square. To calculate a cube ma. To calculate a cube, shift 4 3 shift x square ma. Shift x square if you press, you will have x cube. So you will get a cube. Like this, one can easily calculate a square and a cube in the calculator. For this matrix, a square is minus 1 0 0. Next minus 1 2. Next minus 1 0 1. Like this, if you want, you can check ma. Next, a cube can be calculated like this ma. A square into a. You need to multiply a square with a ma. Then you will get a cube. A cube will be minus 1 2 minus 2. Minus 2 2 minus 1. Minus 1 1 0. This is a cube ma. After calculating a square and a cube, substitute these all in characteristic equation in a. What is characteristic equation in a? Minus a cube plus a square minus a plus I ma. Sorry, here whenever if you have a constant, then you need to write I. We cannot add one number for a matrix, that's why. Now, what is a cube ma? A cube just now I written minus 1 2 minus 2 minus 2 2 minus 1 minus 1 1 0 plus a square ma. A square is there minus 1 0 0 minus 1 minus 1 2 minus 1 0 1 minus a matrix ma. A matrix is given 1 minus 2 2 1 minus 2 3 0 minus 1 2 plus I 1 0 0 0 1 0 0 0 1. If you simplify these 4 matrices ma, finally you have to get null matrix as answer. If you get null matrix as answer, then Cayley-Hamilton theorem is verified. That means A satisfies its characteristic equation. A satisfies its characteristic equation. So one part is over. Next we need to find A inverse ma. To find A inverse, what I said, to find A inverse, write characteristic equation in A. This one, minus a cube plus a square minus a plus I equal to 0. Multiply this one with A inverse or divide with A. If you divide, what you will get ma? Minus a square plus a get cancelled. Wherever you get constant, there simply write I plus A inverse equal to O. Now send all the terms to RHS ma. A inverse equal to a square minus a plus I. Minus a square if you take right side plus a square. You know what is a square ma? A square value already calculated. Minus 1 0 0 minus 1 minus 1 2 minus 1 0 1 minus a ma. A matrix is given matrix 1 minus 2 2 1 minus 2 3 0 minus 1 2. This is 3 ma. Plus I is 1 0 0 0 1 0 0 0 1. If you simplify these three, you will get A inverse ma. A inverse is minus 1 2 minus 2 minus 2 2 minus 1 minus 1 1 0. This is A inverse. If you simplify, you will get, or you can calculate A inverse using calci also ma. To find A inverse. A inverse also you can calculate ma. How to calculate A inverse? After saving matrix like this on mode 6 1 1, enter elements, next AC, then you need to press shift 4 3 x inverse equal to, you will get directly A inverse in your Casio calcima fx991es or fx991es plus calcis. Next, you can find det A also ma. This det A value here I calculated na. That det A also you can get in calculator like this. After saving calci, first save the matrix in the calculator. After saving matrix in the calculator, shift 4, that seventh option will be dead ma. Seventh option will be dead. Again, shift 4, 3 equal to, you will get dead A ma. Similarly, you can solve this equation also using calculator ma. That is not needed here. Next, we will discuss in the next concept how to solve this equation. Okay ma? Are you clear? How to verify Cayley-Hamilton theorem for given matrix. Next problem on Cayley-Hamilton theorem ma. Actually, question will be like this: verify Cayley-Hamilton theorem and hence find its inverse. To verify Cayley-Hamilton theorem, we need to find characteristic equation, because Cayley-Hamilton theorem says every square matrix satisfies its own characteristic equation. That's why first write characteristic equation of A. Characteristic equation of A. That is det A minus lambda I equal to 0. Det A minus lambda I means that 1 minus lambda 1, 3, 1, 3 minus lambda minus 3, minus 2, minus 4, minus 4, minus lambda equal to 0. Now we need to find characteristic equation ma. The technique I said, how to find characteristic equation: minus lambda cube plus sum of diagonal ma. Sum of diagonal elements, add these all. What you will get ma? 0. 1 plus 3, 4. 4 minus 4, 0. 0 lambda square minus sum of cofactors ma. Sum of cofactors of principal diagonal. 1 cofactor, 3 into minus 4, minus 12. 3 into here. Like this I am going to calculate. 1 corresponding column row is eliminated. What is remaining you are having? 3 minus 3, minus 4, minus 4. So 3 4s are minus 12, minus 4 3s are 12, minus 12, minus 12, minus 24. Next, for 3 ma, 3 corresponding column and row are eliminated. That means second row, second column eliminated. 1 3, minus 2, minus 4. 1 into minus 4, minus 4 plus 6, you will get 2 ma. Next, for minus 4. Minus 4 corresponding column row is eliminated. 3 minus 1, that is 1 1 1 3, 3 minus 1 2. Now if you add, what you will get ma? 4 minus 24 plus 4 minus 20 you will get. Minus 20 here, minus into minus plus 20 lambda plus det A equal to 0. Det A, you know how to find det A ma? Det A already I said, by writing cofactor signs like this, plus minus plus 1 into 1 corresponding cofactor ma, minus 24, minus 1 into 1 corresponding column row is eliminated ma. 1 into minus 4, minus 4, minus 6, minus 4, minus 6, minus 10. Next, plus 3 into 3 corresponding column row is eliminated. Minus 4 plus 6 you will get. Minus 4 plus 6 plus 2. Now what are the values you are having? Minus 24 plus 10 plus 6. Minus 24 plus 10 plus 6. That means minus 24 plus 16, minus 8. Minus 8. So here plus into minus, minus 8 you will get. Minus lambda cube. So equation is minus lambda cube plus 20 lambda minus 8 equal to 0. This is characteristic equation ma. Now write in characteristic equation in the place of lambda A. Write in the place of lambda A. What you will get? Minus A cube plus 20A. Whenever if you have constant, there write I, 8I equal to 1. Next we need to calculate A cube ma. Without calculating A square you cannot calculate A cube. That's why first calculate A square. Just now I said ma, how to calculate A square using calculator also. In the previous problem I said how to calculate A square using Casio FX991ES calculator. Using that calci you can calculate so that you can save the time. That's why. So A square is minus 4 minus 8 minus 12. Next 10, 22, 6. Last one 2, 2, 22. Ma. This is A square. Ma. A square. Next we need to calculate A cube. A cube is A square into A. You need to multiply this one with this. Then what you will get? A cube you will get. Ma. A cube is 12, 20, 60. Next 20, 52, minus 60, minus 40, minus 80, minus 88. This is A cube. These two you can calculate using calci also. Ma. That procedure also I said. Next, substitute these values in characteristic equation in A. In this, minus A cube plus 20A minus 8I equal to minus A cube. What is A cube, ma? 12, 20, 60, 20, 52, minus 60, next, minus 40, minus 80, minus 88 is A cube. Next, we need to write A, 20A, A value, ma? 113, 13 minus 3, minus 2, minus 4, minus 4, minus 8I, minus 8, 1, 0, 0, 0, 1, 0, 0, 0, 1. I is identity matrix of order 3. If you simplify this one, finally you have to get 0 matrix as answer mark. So that we can easily say the matrix is satisfying its own characteristic equation. If matrix A satisfies its own characteristic equation, then what we can say, A satisfies Cayley-Hamilton theorem. Hence Cayley-Hamilton theorem is verified. Cayley-Hamilton theorem is verified. After verifying Cayley-Hamilton theorem, now we need to find inverse of the matrix A inverse. So to find A inverse, what we need to do, ma? I said the procedure very clearly. To find A inverse, first write characteristic equation in A, this one, minus A cube plus 20A minus 8I equal to 1. So you can divide this equation with A or multiply with A inverse so that you can get A inverse from this equation. Multiply with A inverse. If you multiply with A inverse, what happens? A cube into A inverse, or divide with A. Your wish? Minus A square plus 20. A into A inverse get cancelled. You will have constant. Wherever you have constant, there write I. Minus I by I into A inverse equal to. So finally, A inverse equal to 1 by 8 into minus A square plus 20I. So A square you are having, ma? A square is here. I matrix, you know, if you substitute and simplify, you will get A inverse like this. 1 by 8 into minus A square means you need to multiply every element in A square with minus, ma. What you will get? 4, 8, 12. Multiply with minus. Minus 10, minus 22, minus 6, minus 2, minus 2, minus 22, plus 20I. Multiply I matrix with 20. This one you need to multiply with 20. What you will get? 20, 0, 0, 0, 20, 0, 0, 0, 20. So this one, if you can simplify, you will get A inverse very easily. A inverse. So here we can easily simplify. 4 plus 20, 24. 8 plus 0, 8. 12 plus 0, 12. Next. Minus 10 plus 0, minus 10. Minus 22 plus 20, minus 2. Next. Minus 6 plus 0, minus 6. Next. Minus 2 plus 0, minus 2. Minus 2 plus 0, minus 2. Minus 22 plus 20, minus 2. So, like this, one can easily calculate A inverse without using adjoint A by det A formula using Cayley-Hamilton theorem. This is the most important application in Cayley-Hamilton theorem. Along with this finding inverse, you can calculate some higher powers of A also. If you want to calculate A power 4, simply multiply this equation with A. You will get A power 4. If you want to calculate A power 5, multiply this equation with A square. Like that, one can easily calculate powers of matrix and one can easily calculate inverse of a matrix using Cayley-Hamilton theorem.